So, are we okay with this now? To lavalier? You can hear me? Okay, good. What we're going to talk about tonight is two subjects, really. Well, the first subject is sort of modern quantitative schedule risk analysis using a methodology which actually splices quite nicely with qualitative risk analysis. If you remember the processes in the PMI guide, the risk analysis has been split into qualitative and quantitative. But if you remember, when you read the PMI guide, you probably said, wait a minute, how do they relate to each other? Because in the qualitative section, I was talking about risks and their probability of occurring and the impact if they do occur. And then you got into the quantitative side, and all of a sudden I was putting 3-point estimates on activities. And you said, where did the risks go? And in fact, it always bothered me. But now we have methodologies which actually continue the use of the risks, identities with probability and impact in the quantitative side, as called risk drivers. I had something to do with its development about 6.5 years ago. And so we're going to talk a little bit about that. This is cutting edge stuff. I mean, it's not new for everybody, but many of you are still in the area of wanting to put 3-point estimates on your activity durations or your cost estimates. And that's really not the way we do it anymore. What we use 3-point estimates for is inherent variability, but all the risk events that you identified in qualitative analysis and put in your risk register, they are actually entered into the quantitative Monte Carlo simulation methodology software using those risk events themselves, namely the root cause drivers, the root causes of those 3-point estimates we used to use. And I used 3-point estimates for 15 years. I mean, I'm just as guilty as anybody else. But we now have better methodologies, and that's the first thing I'm going to talk about. The second, but still more developments in there. I think you'll find it pretty satisfying intellectually. Secondly, comes the question of, okay, if time is money, doesn't time risk have something to do with money risk? How can you estimate cost risk without taking account of schedule risk? Because schedule risk causes some of your resources to work longer hours, many more days, months sometimes, and they're going to be paid. Now, if you've got a fixed price contract in this environment here in the Middle East, probably the people who pay it are the contractors. Okay, so then the contractor should be doing the risk analysis and put the contingency of cost for the extra hours and extra days and months that are worked in the risk analysis of the schedule into their bid. In the United States, where the lump sum contracts are basically vague suggestions as to how much it's going to cost, the owner will probably pay. And in some other countries where you're talking about a national company, such as a national oil company, the national oil company is not going to sit there and force its domestic suppliers into bankruptcy. So the local national oil company is going to pay. So there are two things. One is using risk drivers, and the other is enhancing our accuracy of cost estimate, therefore cost contingency reserve estimating, and the source of those contingency reserves, namely which of the major risks are going to be high priority in determining our need for extra time for the schedule and extra money for the budget. So we're going to talk about both of those. So I'm going to start by just reminding you that the traditional 3-point estimate of activity duration starts with the activity that's impacted by the risks. And we put 3-point estimates on there, and we've used that for many years as a measure of the entire risk of the activity duration, or the entire risk of the cost estimate line item if you're talking about cost risk. And so the three-point estimate is supposed to represent risk. But you and I know that that's not the root cause. The root cause is whatever causes the estimate to be uncertain, and that is usually a root cause risk. And sometimes a risk will affect multiple activities. So to get the entire effect of a risk on the project schedule, which is what we're talking about, you have to look at the risk as it affects multiple activities. But when you put the three-point estimate on the activities one by one, you can't do that. Partly because you don't know which of the two or three risks you were thinking of actually was most important. Oh, and by the way, the three-point estimate is really an estimate of impact, not an estimate of probability. But you know that the definition of a risk is an uncertain event or condition that if it occurs has a positive or negative impact on at least one objective, right? So it's got an uncertain possibility of occurring. Where is that represented in the three-point estimate? And I used to argue that it was represented in the three-point estimate, but I was wrong. It's not really there. It's just a three-point estimate of impacts. So those are the images of the various risks that affect that activity duration imposed upon the activity duration itself. And then you do a risk analysis, which is a Monte Carlo simulation, and you pick durations from that. But you don't really have a way to trace back to the root causes. So guess what? When we get to the end of the analysis and we want to find out we want to be able to tell management what to do next. And risk mitigation is the obvious answer. Oh, wait a minute. We don't know which risks are important when we're doing three-point estimates directly on activity durations. We don't know which of the risks affected that one activity duration. And by the way, there may be multiple risks that affect the activity duration. And one risk may be more important than others because it affects many activities. 20 activities, 50 activities, 100 activities. If somebody says there's a risk in the construction phase, you might be assigning it to all construction activities, or all piping activities if it's a piping risk, or all structural if it's a structural risk. Okay, so then you have the idea that risks can affect multiple activities, and some activities are influenced by multiple risks. It's time to get back to basics, get back to the fundamental root cause of those variances. So we are going to do that in something called the risk driver method. So some problems with a traditional approach: we can tell which activities are critical and sometimes which paths are critical. Trying to get the criticality index, which means which activities and paths were on the critical path in the most of the iterations during the simulation. So we ended up with saying that a risk, that an activity is very likely to be on the critical path. That does not say what risk is important. And we don't mitigate activities. We don't mitigate paths. What are you going to do? Not do the activity? Is that your mitigation plan? This activity is critical, so I'm just not going to do it. No, we don't do that. Okay, but we do something called risk mitigation, and the idea is to find out which risks are important to mitigate, and sometimes you're surprised at that. Makes poor use of the risk register that is usually available. The three-point estimate really doesn't use the risk register, and that was my complaint about the stuff that I was writing about moving from qualitative to quantitative risk analysis. We just forgot about the risk register when we started the quantitative analysis process. Okay? Turns out that we find these days that the risk register is incomplete. I'm sorry about that. If you spent a lot of time and bought some risk register software like Active Risk Manager, unfortunately, the substance of the risk register is not complete. And I find this out how? In doing my quantitative risk analysis, I interview people one-on-one, and I promise them confidentiality. I promise them that their boss will not know what they said. That these 30 people I interviewed for the quantitative parameters, but I won't tell you that this person said that. So all of a sudden people can speak freely. Their boss is not in the room, and we won't tell the boss what they personally said. All of a sudden they start talking about risks that, believe it or not, are not in the risk register. Why do they do this? Because in a workshop setting, they can't talk about these things. That's how the risk register was developed. But in private, confidential conversations, that's when they can be honest and confident and straightforward and understand that they will not be punished. All of a sudden, we get new risks that are not in the risk register. I'm sorry about that, but you've got to look at your risk register and find out, are there important risks out there that maybe are embarrassing, maybe highly pessimistic about the project, political risks that we just don't talk about? Aha. There are some things that we don't talk about except in private. Well, I provide this private conversation. And that's where I find out that some of the most important risks are not in the risk register. And I just want to warn you about that. If you're feeling warm and comfortable about your risk register, don't fall in love with your risk register, because it's not complete in my experience. And we cannot decompose the overall schedule risk into its component by risk with a traditional approach. So, sorry, I have a bit of a cough here. They worked me too hard these last 3 days. But by the way, it's so nice to see so many of you here. Thank you for coming. Okay, so for each risk, we're looking at the root causes of risk now, and we're looking at the risks themselves. And for each risk, I want people to identify it, specify it according to the risk statement, and then tell me what's the probability it will occur on this project with some measurable impact. I mean, not just I like to ride my bicycle. Well, if it's raining, what's the probability it's going to rain? Well, that's one number, but what's the probability it's going to rain hard enough so that I really can't ride my bike? That's maybe a different number. So we want to make sure that what's the likelihood that a risk will happen with some noticeable impact. Okay, what's the impact on time if it does? And here we're not talking about the impact on the overall finish date. We're talking about the impact on durations of the activities it affects. Well, it might affect long activities and short activities and all that, so we're going to use multiplicative terms. So if I say the worst case, if this risk occurs, is that the durations will be 30% higher, that's a 1.3 multiplicative factor. Maybe the best case is 0.95. Maybe you could, in fact, imagine if this risk, let's say productivity of construction labor, is actually better than we assumed, assuming that there's something that could be better than we assumed because, in fact, we made an optimistic schedule to begin with. Sorry. Then maybe the durations could be 5% shorter. Or maybe most likely it's 1.1. In other words, we think that most likely we have overestimated labor productivity in the schedule. And most likely it's going to be 10%. The activities that it's assigned to will be 10% longer than they are in the schedule. That often happens, guys. The most likely impact may not be the number in the schedule. We use multiplicative factors so we can assign the risk to many different activities of different lengths. And the multiplicative factors, while an assumption for convenience, is not a bad assumption. Okay, so we ask then, which activities will it affect? And the people in these risk interviews are going to say things like, well, it affects all structural steel, or it affects all piping, or it affects all earthwork, or it affects instrumentation, or something like that. They won't know that my schedule has 1,000 activities or 2,000 activities, and when they say piping, I've got 40 activities that I have to assign it to. But you have to assign it to the basic activities. Interviewee doesn't get that detailed. These risk interviews, when you're talking about risks, there are like 30 risks you start out with, or 20 risks. You may build it up to 35, and then you whittle it down to eliminate the duplicates and things like that. So you end up with 25 risks for a big project. I mean, I had a $10 billion refinery project in Saudi Arabia. I happened to be able to do this analysis in Houston, Texas. We ended up with 780 activities in the schedule, summary schedule, and we had maybe 30 risks for a $10 billion project, or a nominally $10 billion project. It never was actually, it wasn't built, at least not by ConocoPhillips. But some of you may be involved with it. It's the Yanbu project. Starting with the risks themselves gives us the benefits of linking with qualitative analysis, estimating the impact of specific risks for priority mitigation purposes, and a very big influence, correlation happens automatically. When you start with the risks themselves, you are essentially modeling correlation by putting the same risk on two different activities, right? Because if the risk happens, it happens for both. If you pick a number, a multiplicative factor of 1.12 for that particular iteration, that's the factor that's assigned to each of the activities it's assigned, that's applied to the duration of each activity it's assigned to. All of a sudden, the one risk being assigned to multiple activities make those activities correlated and gives them the right correlation coefficient value. So all of a sudden, we don't have to guess about correlations anymore. And I'm sure all of you lie awake at night worrying about correlation coefficients. I know you do. You just aren't willing to say so. So let's take a simple example of risk register risks. Okay, I've got technology may be more difficult than planned. The way that's stated, it can't help you. So the optimistic value is 100%. The very best you can do is what's in the schedule. The most likely is 10% more, and the pessimistic is 30% more than that, and it makes a triangular distribution, and for every iteration, it will choose from that triangular distribution the multiplicative factor that is assigned, that is applied to all activities that risk is assigned to. This one happens to be 100% likelihood because somebody said, it's happening now. And you say, wait a minute, David. A risk with 100% likelihood is not a risk at all. It's an issue, isn't it? Well, let me tell you, I argued that point at a conference in the year 2000. But in fact, if there is still an uncertainty about the impact, I don't care what you call it, we have to include it, right? So that even with a risk that's 100% likely because it's happening now, if the impact is uncertain, we have to include it. And the best place to include it is in the risk analysis because there's no definitive way to include it in the raw schedule itself. Technical labor productivity may vary. Labor productivity may vary. In fact, it could be higher, and therefore the durations could be 10% lower. But it's not always higher. It could be, productivity could be lower, so it's 15%. That risk is only 50% likely to happen. So what happens? 50% of the time, it doesn't happen at all, and the durations of the activities are okay, at least from that risk alone. And we've got construction labor productivity. Okay, that's another thing. Notice, as I said, that the most likely is 110%. A lot of people will say the most likely is the number in the schedule, the duration in the schedule for the activities. But that's not always the case. I don't know about you, but there must be somebody in this room who has been on a project where the schedule was overly optimistic. I remember a project where even IPA said, if you're in the top quartile of companies doing this refinery type expansion, it'll take 36 months. And management said, I want a 32-month schedule. Now the scheduler, and I know him, and he told me, he squashed activity durations and put activities in parallel and all that, and gave them a 32-month schedule that everybody on the project called magic numbers and did not agree with, did not follow, had no ownership of a 32-month schedule. Funny thing, when I interviewed for risks, and I was still using 3-point estimates, I got the most likely durations, and I put the most likely durations into the remaining duration column, pressed F9 on P3, Primavera P3, and got 40 months. In other words, the people literally did not believe that they were in the upper quartile of all of all companies that do this kind of work. And my risk analysis said that it was actually 45 months at the 80th percentile. So I made my report, and they said, wait a minute, it can't be, it can't be 45 months because we have a 32-month schedule. Number one, nobody believes that. Nobody believes the IPA number because that's based upon an assumption that they don't agree with. And the risk analysis showed that it was only 5 months beyond that, but they didn't like it. So they threw the report in the trash can. They paid my fee. As those of you who are consultants, you understand that's the most important part. And then, about 6 months later, one of the risks that I had insisted on putting in there over their objections occurred. And they'd already lost 6 months. I mean, I was right, they were wrong, but they couldn't see it because they were blinded by the fact that their schedule was 32 months when really even their own people thought it should be 40. So that happens sometimes. So that's why sometimes you have a most likely factor that is not 100, but more than 100 usually. Okay, risk factors mechanics. Okay, I'll just tell you, if the risk occurs on some iteration, a number is chosen from these ranges. Triangular distribution is made. That's all they have. And that is the factor that is multiplied into the durations of the activities it's assigned to. So you get the probability that it occurs. If it occurs on this iteration, there's a multiplicative assignment. If it doesn't occur on this iteration, the multiplicative number is 1.0, which is neutral, will not change the duration. Okay, so that's the risk factors mechanics. Let me just go on. This is a picture of a risk factor that's 100% likely, optimistically 90%, most likely 100, pessimistic 115. And you're probably saying, David, why are you up there wondering about all this stuff when it looks like the triangle we used before? It does. Because I am assuming that only one risk affects this activity and that it's 100% likely. But hang on, it's going to get a little more interesting. Assigning a probability less than 100%, let me just show you the pictures. Aha! All of a sudden, I'm putting out probability distributions on durations. I'm creating probability distributions on durations during the simulation that you can't make putting triangles or any other kind of distribution directly on the activities. These spikes here represent the possibility that the risk does not occur. If I've got a 60% risk, there's a 40% probability that that does not occur. I'm applying it to an activity that's got 100 days duration, just to show you how it would work. At 100 days, I've got 40% of the probability. The other 60% is in this triangle here where the risk has occurred. All of a sudden, you say, I've never seen a probability distribution that looks like that, right? Has anybody here seen that distribution? Anybody? Anybody? One. What? Well, maybe I showed it to you the other day. Okay. I think I sent him a paper the other day. Okay, and the same thing here. I've got a 30% risk, so this spike includes 70% of the probability, and like that. And some people say, I don't like those probability, I don't like those distributions, but they're right. They represent both probability and impact. 3-point estimates directly on activities, you don't have a concept of probability of the risk not occurring. But I do. But still, each one of these only has one risk assigned to the activity. So let's see, assigning more than one risk to an activity. Obviously, if risk can be assigned to multiple activities, and one risk might affect all construction, and another risk might affect all piping, another risk might affect all instrumentation. Pretty soon you have some of the piping construction activities actually being affected by 3 or 4 or more risks. That's partly because the risk interview is held at a sort of strategic level. And they're talking about phases being affected, and that's all they say. But you got a lot of things affecting the construction phase. You got the fact that the contractor isn't reliable. You got the fact that the labor productivity may be estranged. You've got a lot of different factors. So all of a sudden, you realize that activities can be affected by multiple risks. There are actually two different ways in modern risk management software that risks can occur when they're assigned to activities. And this is a very recent development. It's a development in Primavera Risk Analysis. Used to be PERTmaster. Now it's Primavera Risk Analysis. And it's a development in some other new software packages that are coming out, particularly Booz Allen Hamilton, which is a big consulting firm in the United States, have developed something called Polaris. And they've got this right. They've got this right, as does Primavera Risk Analysis. Okay? Well, what happens when two risks are assigned to an activity? Well, the impact is really how long it takes to recover, and you may have the impact in parallel because maybe you can recover from both of those risks simultaneously. So there's a 70% probability of one risk and 50% probability of another risk. On 35% of the iterations, you're going to get two risks affecting that activity. You want to ask yourself, is one of those recovering from one of those risks crucial and must finish first and then you can recover from other risks? Or can you or are you recovering from one of the risks taking all the resources available and you can't recover from two risks simultaneously? And pretty soon you have yourself convinced that you either have to do them in series or you can do them in parallel. Series is what we've always had, parallel in the software packages, but it's really crucial because some of the risks really are recoverable in parallel. So a 20-day and a 12-day risk will be 20 days for the risk recovery, but if they're in series, it's really 32. Okay? So you have to think about which risks there are and how they might react in those iterations, which is your possible project, when both risks occur together. And while we're talking about multiplicative factors, risk drivers, the same thing is applied there too. A 1.2 factor, a 1.05 factor, if they're in parallel, it uses 1.2. If they're in series, it uses 1.26, 1.2 multiplied by 1.05. The problem a while back was that we never had parallel risks capability. So when we had 4 or 5 risks assigned and we multiplied them together, we got duration multipliers that nobody believed. Just nobody believed. And at first, and for a couple of years, the only solution was to scale back on the ranges. Well, that was really the wrong answer, but that was the only capability we had. At some point fairly recently, Primavera Risk Analysis and Polaris, right out of the box, gave us the capability of having these risks in parallel or in series. But Primavera Risk Analysis was really the forerunner of this. 6.5 years ago, they developed this thing called the Risk Factors module. Anybody who got PRA has the Risk Factors module. Well, 6.5 years ago, a colleague of mine and I were doing the work on this large refinery for ConocoPhillips, and we challenged PERTmaster in the UK to make a risk driver, risk factor module, which operates the way I'm showing you. And they'd been acquired by Primavera a year before, and all the original partners were leaving, all except one. And so we caught them as they were packing up their offices. But one of them, Rusty Johnson, was intrigued by this notion, so I think he programmed this in his garage at home. I mean, I think he was literally out the door driving his Aston Martin or Bentley or whatever he bought with his buyout from Primavera, and he programmed this at home. So ConocoPhillips gave him a few bucks, but I'm sure that he spent a lot of more time developing the risk factors module, which I call risk drivers. He calls it risk factors because they are multiplicative factors. But he still likes it. I mean, I contact him once a year or so, and he still says, hey, I'm very proud of that thing. Okay, so I was sort of there at the outset. After two weeks or so of sending things back and forth across the Atlantic Ocean from UK to Houston, we got a working module. And it has since been included in the software as a regular feature. Now, it won't be in your Oracle University course, because I don't think Oracle University knows they've got this module yet. But that's all right. It's in my course if you want it. Okay, never mind. Two risks occur. Each one of these is 100%. So as 2 risks occur. Now, when you were doing 3-point estimates, assigning risks to individual activity durations directly, you might have been trying to approximate this. You say, well, there are 2 risks, and I forget the probability. Let's see, if they both happened, it could go this high. And if neither one of them happened, it could go this low. And pretty soon, you realize that you got 3 risks or 4 risks, and all of a sudden you start thinking, wait a minute, some of those risks may not happen at all, or on some iterations may not happen. And so what's the range? And pretty soon smoke starts coming out of your ears because you can't do the mental arithmetic. Forget that. Let the software model it. Specify the risks, assign them to the activities, and this is the kind of curve you were trying to get. Now, you might have used a beta distribution or something like that, but would you have gotten exactly this, and would you have known how you got it, which 2 risks or 3 risks or 4 risks were involved? This is just much better. You go to root causes, back to basics, and then model how the root causes affect the durations. But these are 100% likely, and 2 risks occur in parallel using risk factors that occur 100%. In parallel, they're 119 days. In series, they're 123 days. So you see the decision about parallel or series risk factors makes a difference. The 80th percentile is 123 days here. The 80th percentile is 119 days when they're in parallel. And if you've got multiple risks, they happen together. But this is still like, okay, maybe you could have approximated this if all you wanted was the finish date of the project. But if you wanted to know what risks cause the finish date, you have to start the model with the basic risks themselves. This is one, again, where there are 2 risks. Neither one of them is 100% likely. One's 40% likely and the other is 50% likely. So the probability in this spike is 60% that it doesn't happen, 50% that it doesn't happen. So it's 30% of the probabilities in the spike. And this is the thing. And you would not have figured this out if you were applying 3-point estimates directly. You just couldn't have built that if you were applying 3-point estimates directly. It comes naturally when you apply the risks, and some of the risks don't always happen. Okay, 2 risks in parallel. This was in series. I've forgotten what the P80 is. I can't hardly read it without my glasses. That's okay. Notice that's something else. Now, I said that correlation is solved this way. You remember how one of the key success factors of a risk analysis is the answer yes to the question, have you considered correlation? Now, particularly like for cost, it's pretty easy. The price of line pipe, or the price of structural steel, or the price of vessels that are made partly from steel are all affected by the world price of steel. And you remember 5 or 6 years ago when world price of steel was quite variable. Okay, well, that's wonderful. It means that it would be an inconsistent scenario for you to have the price of steel high for structural steel but low for steel pipe. It just is an inconsistent scenario because they're both affected by the world price of steel in the same direction. Okay, so they're both, if one's high, the other's high. If one's low, the other's low. That's what's called correlation. But why are they correlated? Because some risk is affecting both of them. Now we're going to model that sucker. We are going to do a modeling of how correlation arises. Okay? It sounds pretty neat because you probably have struggled with a correlation matrix, and you and your colleagues had to put correlation coefficients into the correlation matrix, and you were guessing. I'm sorry, but they were guesses. We don't have an awful lot of databases about correlation. And yet we have correlation. We know that. So instead of picking 30% sort of for everything by default, we were trying to figure out what activity A and activity B were correlated, activity A and activity C were correlated, activities B and C were correlated, and you had to have correlation coefficients for each one of those, and you were sitting in a room with a bunch of your colleagues and guessing badly. Guessing so badly that you could easily come up with an inconsistent correlation coefficient matrix that can be proven using eigenvalue test. Can I use that term? I don't know what eigenvalues are. Determinants, right? You can't have negative determinants. It's got to be positive semi-definite. Now I don't know what I'm talking about, but I've heard that term. Okay. So if you're guessing at correlation coefficients and your guesses can be bad enough so that the software has to perform the eigenvalue test and stop the simulation because your coefficients are internally inconsistent when you're guessing them and throwing darts at the board, basically, you realize that we need to have a better way to look at correlation. Well, if you've got the risks and one risk affects two activities, they become correlated. That's the genesis of correlation. So now let us just say that we're going to do that modeling in the Monte Carlo simulation. And if this one risk, whatever the parameters are, affects activity 1 and activity 2, they become correlated. And if that's all that's happening, they become 100% correlated. And you say, well, nothing's really 100% correlated, but this is a signal. The fact that it may be 98% or 95% or 87% correlated because nothing's perfect, that's the noise. So let's get the signal right anyway. But I say, look, and here's the picture of 100% correlation, and you see they're 100% correlated. That's wonderful. But suppose I've got two other risks. Risk 3 affects activity 1 but not 2. Risk 2 affects activity 2 but not 1. Risk 1 affects them both. So they're still correlated but not entirely. How many of you guessed 37%? How many of you come on. How many of you guessed 37%? I couldn't either. If I had this kind of a problem, how would I know it's 37%? But I know it's 37% because I ran the simulation 3,000 times, took the results into Excel, and ran the correlation calculator. And by golly, they're correlated 37%. Number one, I couldn't have gotten it. Number two, I don't care what the number is anymore because I know that the correlation coefficients are modeled how they occur in real life. They are internally consistent. It's been proven that they are internally consistent. You'll never get an inconsistent correlation matrix when you use this method of modeling to generate the correlation coefficients. And at the same time, I don't care what the value is because I also know that correlations are being used appropriately and accurately in the generation of the results. So I don't need to know what they are. I've got faith that the methodology now has given me the ability to ignore correlations. Doesn't mean correlations are not generated. Correlations are in fact generated. And their implications for the results are generated during the Monte Carlo simulation. I just don't need to know anymore. That's a big relief. Have you looked at correlations? Yes, sir, I've looked at correlations. My methodology creates the correlations. I don't have to generate and guess on the correlation coefficients anymore. And this is a picture of that, 37% correlated. Okay, now, you've seen tornado diagrams, right? Right? You've all seen tornado diagrams. And they usually say activity 1 is highly correlated with the final date, and activity 3 is correlated with the final date, and activity 2 is correlated with the final date. And the most correlated is the one with the longest bar, and somehow that's supposed to tell you something about, how important one of these activities is. But now wait a minute, we don't really care which activity is important. What we care about is which risk is important. And in the risk factors module and in Polaris, for instance, you will get risk 1, risk 3, risk 2. This is a risk tornado, and you should be able to get a risk tornado for cost as well. I think that capability was broken. I'm not sure they fixed it or not. Okay, so now all of a sudden, I'm starting to get to the payoff, which is risk mitigation. And you want to mitigate the highest priority risks. And what are the highest priority risks? Well, the risk tornado diagram, where the risks are the argument, not the durations, not the activities, the risks are the arguments down the stub here. starts to tell me which risks are important. But you got to remember, this methodology of fixing up a sensitivity graph is based upon how the risks are correlated with the finish date. Correlation coefficients have something to do with the mean, right? Squared differences from the mean for one variable versus squared differences from the mean of the other variable. I don't care about the mean. Sorry, I don't care about the mean. I care about the 80th percentile or 70th or 90th or whatever your target is, but it isn't the mean, or it doesn't have to be the mean. There's some organizations that are aggressively organized around the mean, but I think that that means a coin flip. You either keep your job or lose your job with a coin flip. So I don't think that many of us are really going to adopt 50% or mean or anything like that. So first of all, the concept is not what we need. Secondly, guess what? There could very easily be spurious correlation. So I view these risk tornadoes as wonderful starting points to figure out which risks are very important. But they're only starting points, number one. And number two, well, let me show you what I'm talking about here. I'm going to talk about it in terms of integration of cost and schedule risk, because I'm going to use risk drivers in the integration of cost and schedule risk as well. Notice that I have a picture here. Here's the risk. Now I've got project schedule risk, and I'm using risk drivers, and so I get project schedule risk almost as a byproduct, but it's a very important byproduct. A lot of people have tumbled to the idea that it's a good idea to finish on time. You know, some of you think it's a good idea to finish on time? Okay. And then there's cost risk. Well, cost risk is interesting because it has two fundamentally different components. One is time-independent costs, such as the cost of raw materials, the cost of procured equipment, where they may come in late or early, but that doesn't necessarily relate to how much they cost. The cost may be uncertain for a lot of reasons that you would expect costs to be uncertain. People may be busy, they may be overworked, there may be a lot of problems of quality control and things like that. Therefore, the cost can be different, but not because of time. And these are generally resources that are considered and called material resources in the scheduling software. But there are time-dependent resources, and a lot of them are really mostly dependent resources. People, rented equipment, tower cranes, drill rigs, lift barges, things like that, where if they work an extra month, they cost more. And some of these barges, by the way, cost, $700,000 a day, whether they work or not. Some of these burn rates per day are actually very large. Well, the time-dependent resources have the combination of the burn rate per day and schedule risk to give you time-dependent costs. Now, it turns out that if the burn rate is fixed, then schedule risk is the only thing that's driving time-dependent costs. If the burn rate is variable, and we can do that as well, I identify some risks that affect the burn rate, then if the schedule is wonderful, you'll still have variable time-dependent costs. It turns out that both are true, that the schedule is not perfect, and the burn rate is not perfect. Estimate of the burn rate is not perfect. Therefore, both of those things add to the uncertainty and time-dependent costs. You got time-independent costs that may be uncertain, but not because of time, and the two of them drive into project cost risk results. So all of a sudden, we realize that integration of cost and schedule risk is going to give us a cost risk result that has a component, and the proper component, because it's dealing with the type of resource, proper component of schedule risk affecting the duration of activities and therefore the use of time-dependent resources. Okay. So now we've got that, so that the main reason to look at integrated cost and schedule risk is the extra accuracy it gives us in cost risk analysis. Frankly, I don't know how you do cost risk analysis without referring to the schedule. I've seen it done. I mean, it's not a religious thing with me. I've seen it done, except that I don't believe it, because you're missing a fair amount of influence on the cost contingency reserve. And also, you can't identify, unless you use the risk drivers approach, you can't identify which risks are important. And it turns out that some of the risks that are most important in driving the cost contingency reserve needed, say at the 80th percentile, are schedule risks. Sometimes as much as 40 or 50% of the cost risk is really derived from this interconnection here, and schedule risk is driving that. If you don't do an integrated cost schedule risk analysis, you're going to miss a lot of cost contingency reserves necessary. Right? So this is a problem. This is why we do integrated cost schedule risk analysis. I did my first one about 8 years ago with an old P3 schedule, believe it or not, that had extensive resources done, and we challenged PERTmaster to allow us to vary the cost by the duration and vary the burn rate, if possible, for dependent costs, and vary the total cost of time independent resources, and do like this. They did it. This was 8 years ago, before PERTmaster actually did it for real. Okay, so in a case study to illustrate the integration of cost and schedule risk, I'm going to use an offshore gas production platform. It's about 20, 25 activities, because that's what I can fit on a PowerPoint. But it's reflective of a lot of things that I've done, say, for Petrobras in Brazil or Petronas in Malaysia. So, okay. So let's go to there. I've got time-dependent resources such as labor and rented equipment. Time-dependent resources vary, costs vary by the duration of uncertainty and the uncertainty in the burn rate. Now notice that we are doing cost risk analysis using the schedule as a platform. It's not the Excel spreadsheet, it's the schedule that is the platform. Which means that we have to be putting costs onto activities, and you say, oh, no, I don't want to do resource loading of my schedule. It's too difficult. It takes too much time. Well, first of all, I'll point out to you that some of your projects are multi-hundred-million-dollar projects. What do you mean it takes too much time to load the resources on the schedule when you've got $100 million at risk? Give me a break. You could hire me to do it. At my rate? Well, no, anyway, never mind. You talk to Tahar about that. But you've got $100 million at risk. What do you mean? I've got an internationally large consulting, engineering and construction company that if I said the name, you would immediately recognize. They've just told me that they're not going to do any of this because it's too hard to load resources onto activities. Number one, I think that's baloney. They really just don't want to do it. And I'm surprised at this big company, an internationally recognized company, that doesn't want to do it. But secondly, we don't need detailed resources. We just need resources that are good enough to allow us to put the entire estimate into the budget, into the schedule on the right activities. And in fact, some of my associates or some of my colleagues in Australia just use two resources, time dependent and time independent. They don't want it. We're not putting resources on the schedule to manage resources. These are not enough detailed to do resource leveling or anything like that. It's to get the budget on the right activities. Now, somebody else says, well, I can't load at the activity level because my cost budget is not that detailed. Okay, load at a summary level. Create hammocks and load some resources on the hammock level for if you've got costs estimated at phase level or something like that. That'll work just fine. The more you can put the resources on the activities, the better you can estimate your risk-adjusted cash flow accurately by month. But at the same time, you don't really need to put them on the most detailed activities. And by the way, I'm going to suggest to you that we use an analysis schedule rather than the detailed schedule. Oh no, the schedulers in the audience are saying, do I have to do two schedules now? Well, let me tell you. Give me a 10,000 or 20,000 activity schedule, detailed schedule. Unfortunately, it doesn't agree with international best practices. It takes days, weeks, months to debug. Give me a 500 activity schedule that mimics the large schedule with the right dates and the right amount of float on the main paths. And I can debug a 500 to 1,000 activity schedule. In Malaysia, we were using 1,200 activities, but 500 of those were historical, so we really only had about 700 activities to go. So we had a 700 activity schedule. For the $10 billion, 400,000 barrel a day refinery project, we didn't have a contractor. But we wanted to do a risk analysis, so the owner, in this case ConocoPhillips, developed a 770 activity schedule. I call that an analysis schedule, not a detailed schedule. And in fact, as I say, we didn't have a contractor, and they begged out of that project before we had a contractor, so who knows. Okay, so look, you're going to put costs on the activities, but you don't have to have detailed resources. Is that so hard, particularly when the benefit is that you get better cost risk estimates, because this is the main way, the best way to incorporate the effect of schedule on cost. Okay, so do a little work. The cost guys would come in and look at the schedule and take maybe 2 days to load it. This is at Petronas when I was just introducing the technique to them. I mean, they'd never done it before. Their cost guys never talked to the schedule guys. The cost and schedule were inconsistent with each other. Because the schedule gets updated every month, the cost estimate does not. Cost estimate does not reflect the impact of the schedule. So when you put costs on the schedule, you sometimes get really screwy daily rates. The daily rate, the cost divided by the working days. I had situations where the same barge would cost $19,000 a day on one to drill one hole and $37,000 a day to drill on the next hole, because the cost estimate and the schedule were not consistent. And the cost guys were just loving the fact that they had already put the entire budget on the schedule, and they hadn't noticed the inconsistency. Why is the risk guy the first guy to notice the inconsistency between cost and schedule? I mean, as a project controls person, if you are, you might want to think of, shouldn't cost and schedule be coordinated? They use the same WBS, and they keep themselves up to date with each other, and the basis of estimate and the basis of schedule are consistent and all that. Well, my finding is that that isn't the case. Mostly it's not the case. Okay, but anyway, that's what we're going to do. Time, independent resources, I talked about that. Okay, this is the schedule, and I don't know if you can read it. It's a little, either my eyes are going or the focus isn't too good. I got approvals, I got milestones, approvals, engineering, procurement, fabrication, drilling, installation, hookup and commissioning, and March 20th, 2000, oh, I got a much better picture here. March 20th, 2016 is when this one's going to finish. That is first gas. Okay, first gas, a very important date. Okay, now, here's what we do. The first thing, and we put in resources. Now notice that the resources are not detailed at all. We did these resources, but you could even summarize them a lot more. But project management team is actually on everything, but I could have made a hammock and put the project management team on the hammock. Detail engineering, procurement, fabrication, drilling, installation, hookup and commissioning, and all that. Those are the only resources we have. We assign them, and we got $1.47 billion for this particular offshore project. Okay, that's a reasonable number. It starts in 2013, January of last year, and ends on 20th of March 2016, so January 13, 14, 15, 16, so that's 3 years and a couple of months. Not so bad. Okay, good. So now we've got individual activities costed out with resources that are distinguished between time-dependent and time-independent, and we've got durations. Well, now what's the next thing to do? Well, I've been commenting about not using three-point estimates, but I will tell you that there are still some reasons to use three-point estimates, namely to represent inherent variability. This is not the entire risk. This is just the inherent variability part. If no risk occurred, no risk event occurs, your projections for duration still are not accurate because human beings and organizations can't do the same thing in the same time reliably twice in a row. There's a little bit of variation, maybe 5 to 10%. And in fact, sometimes the variation depends upon the type of activity. So the variation may be different for construction, than for engineering, than for procurement, than for installation, than for hookup and commissioning, than for drilling. So you may have what Primavera risk analysis calls templated quick risk, which means that I can separately code each of the main categories of activities and put different ranges of, plus or minus 5, plus 10 minus 5, plus 20 minus 10. Small ranges relating to the inherent variability of human and organizational efforts. And I might want to actually put in there as well duration estimating error. Oops, I'm sorry. Those of you who are schedulers, I didn't mean error in the sense that you didn't do something right. I meant that it might be biased. And sometimes it's biased because the schedule is what? A political document and not a professional document. And therefore, in the risk analysis, you may have a reason for showing that there's bias in the schedule duration, and if that's persistent and pervasive across all activities, then you might say, aha, I'll grind that into the three-point estimate. So you might have a three-point estimate that represents inherent variability and estimating error. That's 100% likely to happen throughout the project. So a three-point estimate is not a bad idea, 100% likely. But these are small errors, but they're often skewed to the pessimistic side. What do I mean by that? More likely to overrun than underrun. Think of your project yourself. Think about getting here tonight. Well, don't think about that. Think about getting here tonight. It's a lot more likely that the traffic will be bad and make you late than that you'll be early. Could happen that you're early, but more likely that you'll be late. Durations, it's a lot easier for things to take longer and not so easy for things to be shorter, particularly if the durations have been estimated optimistically. So altogether, they're skewed to the right. That is, more likely to overrun than underrun. The second thing, which I don't think I've got in this presentation, is the merge bias. When parallel paths go along in the schedule and then there's a merge point, the latest of the two merging paths determines the date of the merge point, right? The latest of the two merging paths determines and under some circumstances, one path will be latest. In some other circumstances, the other path will be late. In some circumstances, both paths will be late. And in some circumstances, both paths will be early. Because of the logic at merge points, the only way that the merge point can be early is if both paths are early. If one is 10% late and the other is 10% short, it's late. If they're both 10% late, it's late. Only if they're both on time or early is the merge point early. So even if you have small variations because of inherent variability, you're going to have risk. And you will be surprised to know that, in fact, you may have a lot of risk, enough risk so that the activities, so that the duration in the schedule is very unlikely to occur. For two reasons. One is that the range, even for inherent variability, is skewed to the right. And number two, there are a lot of parallel paths and merge points throughout your schedule, in a real schedule. And at every one of those things, typically, you will have more risk generated at the merge point than you had for either of the merging paths. And so a project manager who says, well, why isn't my schedule at least 30% likely to happen, maybe 50%? I've got good schedulers, I use good schedule software, I don't put any pressure on them or anything like that. Well, it's because it's easier to overrun than underrun, and the structural aspects of a schedule mean that overrunning at merge points is a problem. Okay, so schedule risk with inherent variability. The baseline schedule date was 20th of March. The 80th percentile is 19th of June, April, May, June, so that's about 3 months. Inherent variability by itself gives you 3 months. And I guess we don't see 20th of March. This is the 27th of March. The 20th of March is already sort of less than 1% likely. That's when the scheduler says, wait a minute, you haven't even put the risks on yet. And already my schedule isn't viable. What in the world are you doing to me? And I had one client last year who saw that, the scheduler made that kind of comment, and they went back and changed the data. Changed the input data to make sure that the schedule deterministic CPM date was 30% likely. And I really reamed them for that. I said, first of all, you're changing the data to get the answer that you want. And number two, even if you're right in changing the data, then you have trashed your entire risk register. Because before you changed the data, the risk register and the data that you used were consistent. Now all of a sudden you found it expedient to change the data in order to get an answer you liked, without regard to this risk register that you've been spending months trying to maintain and build up and maintain. I said, I don't know whether this data change was the right thing, but it sure looks suspicious to me. And the project manager turned to the scheduler who was right next to him and said, why did you let me do that? Why did you let me do that? Because the project manager didn't know any of this stuff, and his staff wasn't going to tell him. Matter of fact, his staff was staunchly behind this change in data. Except it was so phony. Never mind. Okay, so we got 3 months for basic data. And by the way, now that we've got costs on there, we've got a cost histogram, right? The $1.473 million is at the 80th percentile, now up to 1.509. Okay, so maybe $30 million more. Okay, now now we're going to put it on the regular risks, the risk events. We're going to use risk drivers. These are the schedule uncertainties, and you don't have to know, but there are 8 of them. These are the cost uncertainties, and if they're applied to a time-dependent resource, they will affect the burn rate. If they're applied to an activity with time-independent resources, they'll affect the total cost. In Polaris, you can front-end load it or back-end load it if you want. Here's the probability over here. Okay, now we're going to apply it to various activities. This is the application. Now, I'm not asking you to judge whether I've applied it correctly or not. These are the risks down here. And some of them, like schedule maturity, are applied to many activities. Some are not applied to too many activities. MTO and specifications, not ready for the invitation to bid. Problems interfacing phases are M4. Cost estimate inaccuracy is immature. It's on several of them, but not on their schedule, only on the cost. So fundamentally, we have this application. That's just the result of the risk interviews. Okay, some risks are in parallel and some risks are in series, and I see that when risks 6 and 7 are in there, they're in series, and the others are in parallel. Prioritizing risks that are in parallel is a little bit difficult because you take one of the risks out and you got the other risks that were in parallel, and so no one risk by itself has much effect. You've got to take them out in clumps to have much effect. I'll show you how to do that. Okay, so this is this is just a 9.6 month schedule delay with inherent variability, which was 3 months. I can't see you, sir. Inherent variability, which is 3 months. I told you I had 300 slides. This guy wants to go home. Okay. The inherent variability was 3 months. The risks themselves added another 6.6 months, and that's sort of reasonable. Inherent variability is important. You probably can't mitigate it, but the risk events will add more more days at the 80th percentile. Okay, so these are risk events, inherent risk completion date at the first gas. This is just a histogram you would have gotten even if you didn't do cost risk. But, and this is the duration, and now here's my prioritization of risks using quantitative methods. Now you realize that using qualitative methods you prioritize risks and you ended up with a risk register, and the risks were prioritized by their probability and impact, and they were on a 5x5 risk cube where they were in a red or yellow or green condition, indicating that they were high risk to a particular objective, like for instance schedule or cost or scope or quality. Yellow, which is moderate risk, green, which is okay. But those were what? Those were judgmentally determined, and if you really thought about it, you'd say this risk affects multiple activities. They may be on risk critical paths or not, or risk slack paths. I don't know about that. How can I judge if this risk occurs? It might add 4 months to the project schedule. If this risk occurs, it'll add 2 weeks to the project schedule. How can I judge it when all of these factors are in play? You don't have to judge it anymore, because here's the way to do that. You take the risk tornado diagram as an indicator of what the top 3 or 4 or 5 risks might be, and then you try them one at a time. And what do I mean by try them? You make the probability 0 for one of the risks. You rerun the scenario, rerun the simulation. You look at the 80th percentile, what date do you get? That is arguably the marginal impact of that risk at that date. And it's in days. But you don't know if that risk is the most important risk, because the risk tornado diagram is indicative but not definitive. So you might have to put that risk back in and try another one and check the 80th percentile date and take that risk out. And you try all the obvious suspects, and you find out that one of them, when you try it, has the earliest 80th percentile date. That is arguably the most important risk at the 80%, and you know that it saves you 53 days. Companies' engineers may vary in experience, however, is a sort of an organizational risk, number one. Number two, it's hard to do anything about it, but it's most important. And it may be most important because it's highly likely, because highly impactful, or because it's assigned to many activities that turn out to be on risk-critical paths. All that stuff is handled by the simulation. You are now prioritizing the first risk. What's the next best risk, next important risk? Well, it turns out that there's a new risk tornado, and you use that to identify the next 4 or 5, and you try them out one at a time with the first risk already taken care of. That is, the first risk is with 0 probability. It's no longer being considered. What does that do? Taking a risk out, finding a risk is probably like finding the thing that is mostly affecting the risk-critical path. But if you zero that out, that may not be the risk-critical path anymore. And in fact, you may find that it exposes a different path. And I had one which was a pipeline, gas pipeline, and the compressor was the longest path in the CPM schedule, and they figured it's risky, so they thought the compressor was the riskiest part. But I looked at it, and there was another path called build line pipe and hauling and stringing, clearing and grading and hauling and stringing along the route. Well, by the way, it was in Borneo, and it was in the jungle, and nobody had ever walked the route before, and there were 300 river crossings, and all of a sudden you realize there's a lot of risk in the line pipe creation, which, by the way, was being done by a company who never had done it before. This project's almost done, by the way, so it's ultimately successful. And clearing and grading and hauling and stringing, particularly when you realize that we don't have access to all the land yet because some of the landowners are not willing to sell at the price we've offered, which means clearing and grading is going to have to be done piecemeal until we get access to all the land, adding to the cost and adding to claimable cost by the contractor. So I don't care about lump sum anymore. This is different scope, different assumption. Anyway, never mind. Okay. Turns out that that was the most important path. But once you took the risk, the most important risk out of that path, it turns out that the second most important risk was, namely the one that had the earliest 80th percentile when you took them out one at a time, the second most important risk was on the compressor path. When you took that one out, the third most important risk was back on the clearing and grading and hauling and stringing route. And those of you who have lace-up shoes know it's sort of like going back and forth on your lace-up shoes. And some of you others with loafers or sandals don't know what I just said, but I understand. It's late in the day. Notice that the third most important risk is 96 days, and you say, Hulett, scope growth may be important than expected. It's 96 days. Why isn't it number 2? Why isn't it number 1? Well, I promise you it wasn't number 1. I promise you it wasn't number 2, because we considered it at every stage, and it didn't give us an earlier 80th percentile date, but when we took those two out, it exposed the path that that one principally affects, and it had a big impact on that path. Okay? So, in fact, it is not the first one to do. You ought to do them in order, because if you start working on something like scope growth, you're working on the wrong risk. And the other risks are dominating, and so you have very little impact on the final activity. But if you do some good work on mitigating that one, then you work on this one. And if you do those good work on mitigating them, and you probably won't completely mitigate them, so the probability probably won't be 0, but then you get to this one, and you've got a fair amount of schedule risk to fix. And you go down, you're down, and finally, the inherent variability and duration estimating is down here. It's 91 days, but it's inherent. You're not going to mitigate that. You've got to live with that. So all of a sudden you realize, I can't get back to my 2nd of March 2016 because the last 91 days, and these are calendar days, this is an Excel spreadsheet, calendar math, are in the inherent category. I've got estimating error there, but there's also inherent. So now that's how you prioritize risks using the schedule, which is what? The document that the program is using to manage the project, pretty credible. And secondly, risk factors, which highlights the risks themselves. So when you take it out, you take out its influence from all the activities it was assigned to. Where in three-point estimate, you couldn't possibly do that. Anyway, okay. So now we have a situation where I am providing a priority list of risks using days that management understands. Management doesn't understand the length of the bars on the tornado chart. I mean, those are correlations. Who understands what correlations imply? But boy, if you say, I can mitigate this risk and it'll cost me $20 million or $50 million, and somebody says, you're going to save me nearly 2 months, month and a half, 2 months, for $40 million on a $1.4 billion program, of course I'll do it. Okay. This is a benefit cost analysis that the project manager can make, but you are the one giving him the data because you got the database and the methodology. You're in the management suite helping make strategic decisions. Here's just taking the risk out in priority order. Some people like this chart. It shows that these things are cumulative. Summary cost risk results. Okay, now all of a sudden I'm going to get cost risk results, but now you know that because it's an integrated cost and schedule risk analysis, these cost risk results have the impact of schedule risk embedded in them. Okay, and this turns out that at the 80th percentile, I'm recommending $263 million, which is an 18% increase over 1.473. In other words, 1.736. Now, usually we tend to validate the cost estimate because the engineering company that you have hired to give you a cost estimate is required to give you a contingency reserve below the line. You would not accept a cost estimate that doesn't have a contingency reserve. On the other hand, for a schedule, somebody gives you a contingency reserve, you say, what's wrong? Can't you manage your project? We don't give schedule contingency reserves here. Why not? It's the same process and the same thing as cost contingency reserve. But somehow the schedule doesn't get contingency reserve, so our results are generally that we sort of validate the cost estimate because they've put a cost reserve in there at the 50th percentile, but because we're doing Monte Carlo simulation, I can recommend a different number. But the schedule's way out of bed. And on occasion, I've had IPA coming in at about the same time, and they don't tell me what IPA says until the end of it, but IPA has the same answer. The cost estimate's not so bad. The schedule is really in need of elongation because the schedule is bad. But that may be in part because we don't allow them to put a contingency reserve of schedule, or maybe they don't know how to do it. Okay. So now where's the cost risk? By resource, you can do that. By type, which is material and labor, you can do that. This is the cost histogram. Doesn't look particularly exciting, except you realize that it's got all the schedule risk in there. You can't do this. You will not get this answer if you ignore the schedule. Now, here's something interesting. On this particular little example, if you take out all the schedule risks, you lose $105 million of contingency reserve. If you put them back and take all costs in, you lose 155. So of the 300 or the $262 million reserve that we were talking about what is it? This is 40% is due to schedule risks. I know because I took them all out and reran it. And 60% is due to cost risks. Again, another reason to tell you that you ought to integrate cost and schedule risk in one analysis. And if you don't miss it, and you might miss a fair amount of that 40% of the contingency reserve that comes from schedule if you don't do integration of cost and schedule risk analysis. And again, you got priorities of risk to the cost, and some of these risks to the cost are large because they cause schedule risk, which is on activities with time-dependent resources. That's all included in here. That's all included in here. And this is the prioritization of risk to schedule. And this is something that you can't do without this. This is a scatter diagram of finish date on here and cost on here. And I believe I figured out that, each one of these dots represents one of the iterations. There are 3,000 dots in here because I did 3,000 iterations. Each one of the dots is a consistent time and cost result because it's from one of the iterations that has a particular set of possible inputs. Okay? And so now we have that. This looks like it's from lower left to upper right a little bit. That's because time is money. The longer it is, the more money it's going to cost for time-dependent resources. But that's not definitive because there are uncertainties in the burn rates and uncertainties in the cost of time-independent resources. Notice where the plan is. The plan is way down here. You're in deep trouble at this point. Okay, this is something else you can do with cost-loaded schedules. You can create a risked cash flow. And so here it is, and again, this is where you're going to be at the end of your plan. However, you're not going to be done and you're not going to be through spending. Because this is the same thing as that, except now I can tell you how you're doing risk-adjusted in each month. And if you've got a yearly budget, let's say, and one of my first ones was on a decommissioning of a nuclear reactor, and I compared the risk-adjusted results to their budget. They had compared the plan to their budget and figured out that a couple of months they're going to be over, but really, on the whole, for the year, they're going to be okay. They're going to be over in 2 or 3 months and not much at that. But when you look at the 80th percentile, you find out that they're going to be over by 6 months, and some of that overage is going to be over $1 million. For this project, that was a lot of money. The project manager immediately took his team to an offsite, and they reprogrammed the thing so that risk adjusted they would meet their budgets. They'd been given budgets by the Department of Energy. They were going to meet those budgets. They hadn't realized that creating a plan for meeting the budgets was not enough. You had to create a plan where risk adjusted it would meet the budget. So they did that. Okay, now this is just an analysis of a mitigation scenario because I want to drive my clients to actually use the results for improvement of the project, not just fatalistically, oh, well, we're going to be 9.6 months late. So I say, yeah, but I've given you priority risks. Now let's take a look at them. And we usually have a risk mitigation workshop. And this is a workshop. This is not individual interviews. This is where the team and the project manager get together and figure out what to do about the risks in priority order. By the way, not all the risks will contribute to the schedule or cost risk. Some of them, for instance, will be on risk slack paths that maybe the risk is serious, but the path is never driving the result. So you may have 20 or 30 risks, but only 10 or 15 of them actually show up in the table. So but I contend that the prioritization based upon using the schedule and the Monte Carlo simulation method and made capable by the risk drivers approach is much more accurate than the red, yellow, green in the qualitative risk analysis. Not that you shouldn't do that, but that this is more accurate when you do it. Anyway, so propose mitigation to the risk that engineers may be inexperienced, increase salaries to accompany engineers to competitive levels. This was a real risk for a number of projects. Okay. I don't know how much it's going to cost, but let's say it's estimated to cost $35 million. The ranges, the probability goes, if you do that, the probability goes from 85 to 20%, and the range, which was 90%, 110, 130, goes from 90%, 100 to 110. This cost risk range actually increases because the cost estimates of this could be too low. Well, if you do that, you're not mitigating this risk 100%, but you are making it go from January 6th to November 14th, and so you're saving 53 days. Interestingly, you're saving $24 million of the cost contingency reserve because some of that was held for the schedule risk that was caused by this risk. So that might help you pay for the mitigation, right? The net cost of the mitigation is $14 million, and you save 53 days. Is this mitigation worth it? Well, I don't know, but those are the kinds of numbers that management needs to be looking at in order to make a judgment as to whether the risk is worth mitigating or whether this mitigation is going to be effective. Now, I want to point out to you that in order for the mitigation to be effective, it has to be executed. You can't just sit there and talk about increasing salaries and increasing training for the people that you do hire. You have to actually do it. You heard the thing about the 4 frogs on the log, right? 3 of them decide to jump in. How many frogs are on the log? There are still 4 because deciding to jump in and jumping in are 2 different things. Okay? You have to decide to do the mitigation, and then you have to literally do it. You have to put it in the budget. You have to put it in the schedule. If you need higher level management approval, you've got to get that. You have to actually do it. It's not going to help your project just to think about it and put it in a model and put it in a report. You actually have to do it. And then you have to assign somebody to monitor it, and that person has to report back to you. And some of these things are pretty vague, but report back to you whatever measures you can create that will help you understand. So anyway, this is the kind of thing where you drive them to risk mitigation. And what does that mean? The results are not a foregone conclusion. The results from the initial risk analysis are supposed to be assisting you to make decisions to improve the possibilities of success. In other words, somebody asked me, and they asked me today in this course I was giving, do you have any evidence that they didn't quite say it this way, but do you have any evidence that your forecasts are accurate? And I said, I hope they're not. What do you mean you hope they're not? Well, I hope that my forecasts got the project team to think. We held the risk mitigation action scenario, and I hope that my initial analyses were overly pessimistic. That is, that they were actually able to use the analysis to improve the project success. That's where we're going. And remember, I'm using the risk drivers method, which allows me to do that. I'm integrating cost and schedule, which is a good idea, and so that's where we're going. Okay, well, NASA, the National Aeronautics and Space Administration in the United States, actually mandates this requirement, that you budget to a date, and you budget to a cost and schedule to a date where there's 70% likelihood of meeting both targets. And they require that at 2 of their key decision points, this is done for their projects. And here's a picture of that. This is 70% likely, which means that 70% of all the dots are in the southwest quadrant. But this is really best viewed as a mound of probabilities, a sort of a ridge of probabilities, and where you're probably going to end up is somewhere in the most dense part of the cluster of points. And so this is the schedule you ought to adopt, and that's the cost you ought to adopt. And this indicates that you're going to be 70%, given the data that you have and the plan that you have, you're 70% likely to meet both cost and schedule. Now, your plan is way down here, right? So this is the contingency reserve of schedule that you need, and this is contingency reserve of cost that you need. But NASA is mandating integrated cost schedule risk analysis. And I was doing it at Petronas. I was doing it at ConocoPhillips. So it can be done, and it's not all that onerous. And I'm surprised when major engineering construction company told me the other day that they thought putting resources or costs onto schedules was just too much trouble. Too much trouble. Their bids are hundreds of millions of dollars. Never mind. Okay. Thank you very much.